Hello, everybody. I'm Chris. I work at Microsoft on the Fabric Customer Advisory team. I am a long-standing Power BI person, long-standing fan of Power Query and stuff. So talking about Dataflows Gen2 should be a kind of natural topic. But I'll admit, I've kind of fallen out of love with Dataflows a bit in the last year or two. Feel like they'd kind of been a bit frustrating. Power Query and Power BI Desktop and Excel. It was really good, I think, when it was first released, and then Power Query got a little bit uncool. People complained it was a bit slow. People complained it was a bit clunky to work with. People complained it was a bit expensive to use in terms of Fabric. So the cool kids kind of abandoned it. Not that I'm a cool kid, obviously. But if you're thinking about what the cool kids are using data to move around, using to move around data these days, if you're not, vibe coding your data engineering scripts with Claude, you're nothing. And certainly if you're not even using AI, if you've got any kind of professional self-respect, it seems like you should be, writing Spark or Python notebooks in Fabric and things. And people look down on data flows a little bit, which is kind of sad. So yeah, I kind of drifted away from. This is the problem with having Teams on. I kind of drifted away from doing stuff with data flows, but I'd seen this kind of steady stream of blog posts and announcements, and things that I thought, I should really check out. And doing a presentation, this is the first time I've done this material, but I'm doing presentations at SQL Bits and the Fabric conference in Atlanta on this, and I thought, well, this is a great opportunity to really get into these things, go beyond the blog posts and actually really get my hands dirty for a long time. Because I don't think anybody else had been doing this. A lot of this stuff that I'm going to be talking about and showing, things like fast copy and partition compute and stuff, nobody's been really doing anything in depth about it. And I kind of thought that was a shame. And in the last week or so, not that I prepare my presentations totally at the last minute, I've kind of really started to learn this stuff and actually, started to fall in love with data flows a bit more again. There's a couple of features, maybe not the really obvious features, but there's a couple of features there that actually make your life a lot easier. And at the end of the day, it's still Power Query. It's still a really amazing visual way of working with data. And so maybe what I'll show tonight is going to make you interested in Power Query and data flows all over again in the same way that it has done with me. I've got slides. My slides are very typical for my slides. They're very wordy and very boring, but it's going to be mostly demos anyway. What are we going to talk about? Well, first of all, we need to address the fact that there are lots of flavors of data flows. We'll talk through that. Then, because this is a Microsoft presentation, I'm a Microsoft person, I have to talk a little bit about Copilot, but there are some really cool things about Copilot. There's a bunch of other new features, and then probably about half the demos are all going to be to do with new performance related features, partition compute, fast copy, staging, things like that. So there are going to be, I think, a lot of interesting things to see, lots of demos. I like to take questions at the end, but I will be around at pizza time and I'll be around a little bit afterwards as well if you want to ask your questions then. So let's get stuck in. Yes, now, there's always confusion with naming. Again, I work for Microsoft, so sorry about all of the naming confusion we have. But there are different versions of data flows out there. In fact, there are 3 distinct versions of data flows. Now you're thinking 3, really? Like there's Dataflows Gen1 and Dataflows Gen2. What's the third one? Well, we've got Dataflows Gen1, which is the old version of Dataflows that's been around in the product for years and years. It's been around since the days of Power BI. It's available for everybody using Fabric or Power BI. It doesn't need a capacity. It can work in pro workspaces. That's Dataflows Gen1. Then when Fabric came along, we had Dataflows Gen2, which requires capacity, and it requires Fabric to be enabled on your tenant. So you can do it on a P SKU or an F SKU. Remember, enabling Fabric is not the same as whether you've got a P SKU or an F SKU. So long as you've got a capacity, either a P SKU or an F SKU, or you've got Fabric enabled, you'll be able to use Dataflows Gen2. And then we have what we call Dataflows Gen2 CI/CD. And in fact, nowadays, this is the default. I'm not even sure you can even create an old Dataflows Gen2 anymore. It is effectively Gen 3, but for some reason, nobody wants to call it Gen 3. And at some point in the future, all of your Gen 2 data flows will be migrated secretly to Dataflows Gen 2 CI/CD, and then there will only be one version of Dataflows Gen 2. Yes, but yes, effectively a third version. This is the version that was completely rewritten to allow for integration with Fabric CI/CD, so Git integration and things like that. This is where all of the cool new features that I'm going to be talking about are enabled. And it was also kind of like a rewrite at the engine level. So there's a lot more reliability, much better performance. And that, indeed, as we'll see towards the end, it's better priced as well. So effectively, for the rest of this presentation, everything I talk about will be Gen 2 CI/CD. At some point, this will be the only version of Dataflows. Maybe one day, I hope. We've got plans for even migrating everything from Gen 1 to Gen 2 and having this work everywhere. But Dataflows Gen 2 CI/CD are where it's at. Okay, so I assume everybody knows what a data flow is, yes? Yeah, we've all played around with Power Query, at least. We all know what a data flow is. And a data flow just allows you to get data, move data from A to B, and it's a very self-service way of working. The idea is if you're not comfortable writing code, it's a nice visual way of interacting with data, and you connect to your data sources, you apply your transformations, and then you output to a destination. Something actually I should have probably mentioned on this slide as well. The key difference between Dataflows Gen 1 and Dataflows Gen 2 is with Dataflows Gen 1, Dataflows Gen 1 were a self-service ETL tool and storage. So when you ran your Dataflows Gen 1, it output the data into some storage that you couldn't see, but you could connect to. But it was Dataflows Gen 1 own proprietary storage. With Dataflows Gen 2 and Dataflows Gen 2 CI/CD, we have destinations, places you can load your data to inside Fabric and indeed outside Fabric. So that's another key distinction between Dataflows Gen 1 and Dataflows Gen 2. Okay, so we've got a self-service ETL tool. And kind of as you would expect, it's got a nice, easy-to-use, intuitive UI, but it's got lots of buttons. It's got ribbons, it's got tabs of ribbons, it's got lots of buttons. I've been using Power Query for years and years, so I know where all the buttons are. But even if you are a person who's got a reasonable amount of Power Query experience, sometimes it can be quite tricky to find where all the buttons are, where all the functionality is. And underneath the covers, you've got the M language, which sometimes you might want to write. It's even more powerful, allows you to do even more cool stuff with data transformations. But wow, that's a very obscure language. And I don't think anybody should really be expected to learn another really obscure language with Power BI. You've already learned DAX, you shouldn't be learning M as well. And this is where Copilot comes in. So Copilot is a natural fit, I think, for Dataflows Gen 2, for people who want to move data from place to place, but don't want to spend time learning the UI and certainly don't want to spend time learning M. And Dataflows in Gen 2 can do all kinds of interesting things. It can explain existing queries, it can create new queries, it can do transformations, and it can do other kind of cool stuff. And I think it works, surprisingly well. It's surprisingly powerful. And I think it is particularly useful for, the kind of people that Dataflows are aimed at. So let's have a look at Copilot. I will zoom in a little bit so that you can see, and I will make sure I'm not standing in front of the screen so that you can see as well. And I will zoom in as well. Am I standing in front of the screen? Can you see? Good. All right, so I've got a data flow here that returns a very simple table of data. Nothing very fancy at all. This is just here to show you what we can do with Copilot. So what are the things? We can explain the query. Now, if I pop out the Copilot pane on the right-hand side, I can write a prompt here. Whoops, might help if I actually spelt it properly. Let's see if it's able to understand it. Oh, it's even clever enough to understand it when I do a typo. It's explained what's going on inside the query for me. Nothing really very interesting, but if you've got some complex transformations there, it will do that. And you can also, if you want, right-click on a data flow. And as you can see, there is an explain this query button there as well. See what's going on. We can add new transformations. So if I was to say here, and I will not risk typing this live, but I've got my prompts on a notepad doc here. I could say, create a new query that summarizes sales by country, kind of a group by type of thing. I can create brand new queries from existing queries and chain them together. There we go. It's created my brand new query, and it has done pretty much what you'd expect. It's done a group by, and it's summed up the sales by country. That's pretty nice. You will also see that it is kind enough to have an undo button here when it says what it's done. So I can just undo that and delete the query. So I can create brand new queries. I could do transformations on existing queries as well. So let's say I want to add a column onto this table that adds a forecast. So let's add 10% to the sales value. It will add a new step in the query. And there you can see that there is my new forecast column. It has indeed added 10% to the query. And there is the M code. So if you can read M, even if you can't read M, it's pretty easy to understand what this has done. It's multiplied by the sales by 1.1, which is exactly what I wanted. That's cool. Let's undo that. That's added a new column. There is actually the option to add a new custom column up here in the ribbon as well. Oops. So there's a new custom column button, which has been around forever. If I click this, you can see that we've got a Copilot box up here. And what I could say here is something a little bit ambitious. So the table has got countries like UK, USA, France, Germany. I can write a prompt here that says, take each country name, and if it's an abbreviation, return the full name of the country. And if I hit send here, there we go. It's writing a DAX expression for me, which again says if country is UK, then United Kingdom. If country is USA, then United States of America, else country. Do even more sophisticated things like this. It can, if you ask it to convert Fahrenheit to Celsius and stuff like that, it will do it. Let's cancel out before we do that. And last of all, there is another column option here called AI prompt column, which does something subtly different. What we just saw is adding a new column, and Copilot generated some M code, which contained the logic for that column. What we can do here with this AI prompt column instead is call an LLM for every row in the table and evaluate prompt for every row. So what are the kind of things that we can do here? So what I've got here is something that says, write a description of the fruit in the product column and tell me if it's popular in the country column. Do so in less than 50 words. So if I tell it to look at product and country and click OK, think about it a little bit. It will want me to authenticate, but that should happen very quickly. And if we collapse this very quickly, let's have a look and see what we've got here. So First row, it says apples are crisp, juicy, sweet fruits, rich in fiber and vitamins. They're very popular in the UK, commonly eaten fresh or used in cooking and baking. So effectively, it's evaluated that prompt once for every row in the table. Now, obviously, you're going to be able to do all kinds of interesting, useful things with this. Maybe you've got comments from your website or something, and you could say, is this positive, negative, summarize the main points or whatever. But you get the idea. So all kinds of useful, interesting things you can do with Copilot, which are useful, I think, for the kind of professional developer, but also certainly for the self-service download. Can I take questions at the end, though? Thanks. All right, so that is Copilot. Moving on, the next thing I want to do is have a look at some of the kind of like other small little bits of new functionality that have been added recently. So let me close out of that and discard those changes. And let's switch back to here and talk about some of these we've got here. Do a few slides and then we'll do a few demos. Parameterized execution. You can schedule data flows to run. You've always been able to do that. That's quite handy. You've also always been able to run a data flow from a Fabric pipeline. And in a Fabric pipeline, you can not only kind of like schedule a data flow to run, but there are all kinds of things in Fabric pipelines, like where you can run for each loops and pass values from one stage to another or whatever. Parameterized execution is something that people have been kind of asking for quite a long time. It allows you to pass parameters from a Fabric pipeline into a data flow. And you do that using data flow parameters. Parameters have been a thing in Power Query since the very beginning. You can declare a parameter, give it a value. What you can do now is pass values into parameters from outside a data flow. You can do it through the API, and now you can do it through a pipeline. Let's have a very quick look at this. It's quite easy to explain. If we have a look at parameterized execution, here is my data flow. And I've got a parameter defined here called demo parameter, which has got the value 1. Quite simple. And then if I look at my parameterized query, what I've done is I've written an expression that returns a table with the value of that parameter in it, which is the value 1. So pretty straightforward. It's a table that contains one row and one column, which is the value of the parameter that I've declared. But I've got a parameter here, demo parameter. Now, if I was to run this data flow now, it will return a table with one row and one column containing the value 1. But if I go to my pipeline instead, and I've got a Fabric pipeline here, I've got a data flow activity. I can run that data flow. And there was something I forgot to show in the data flows dialog. There's an option you've got to set in the options dialog to say allow passing parameters in. I won't go and do that now. But having set that extra option, you can see there is demo parameter. I'm going to set that to be the value 7. And I won't run this pipeline now. But if you want to see what the output of that pipeline is when I load it, or I run it and load the output into a lakehouse, there is my value 7. So now you can create a data flow with some kind of template logic in that's parameterized, and then you can use that from multiple pipelines, filter on different values, change the logic, change tax rates, do all kinds of different things. But you have one data flow that can perform multiple roles. That's pretty cool. Another thing, variable libraries. Is anybody using variable libraries in? Good. So variable libraries are quite a handy feature. Variable libraries are just, well, they're what the name suggests. They are like libraries of variables that you keep in a workspace. So values that you can access from a number of different Fabric workloads. And the idea with variable libraries is, again, you can kind of not only parameterize things, but when you move your Fabric objects from your dev environment to your test environment to your production environment, maybe the variable name stays the same, but the value changes. So you can have different logic, point to different data sources, and so on. Now, Dataflows Gen 2 don't support absolutely everything in variable libraries yet. They do allow you to change the data source that you're using. They don't allow you to change the data destination that you're using, but that's kind of coming soon. And you can get at values and do other things as well. There's no UI support for variable libraries yet, but you can actually get hold of a value from a variable library using two M functions. There is a variable.value function, which just allows you to get the value from a variable library for a particular variable. That's not the function you want to use, though. What you want to use is the variable.value or default function, which allows you to do the same thing, get a value from a variable library, and if the variable doesn't exist, return some default value instead so that it's going to work. But I've got a very quick demo that will show you how that works. There's my variable library. I've got a default value set, which is my default value. And if I go to my data flow, and this is something that's changed in the last few weeks. This functionality was released about 3 or 4 months ago, but at that point, even though you could use these functions inside the data flow editor, and it would work, you wouldn't actually be able to see the actual value from the variable library in the preview. You can do now, but here basically is me calling value.variable.default, getting the value from a variable library, getting the value for a particular variable, and if that variable doesn't exist, return the value X, Y, Z. So there's the value it returns. Again, useful for the one person. It's John, isn't it? I got my reading glasses, but I think it's John. Can't see properly, but yes, I assume it's John. So I would expect someone like John to be using variable libraries. Another fairly kind of random, interesting thing. Relative references. Remember I said you couldn't use a variable library with a Dataflow Gen 2. Anyway, the latest thing happening is being able to have relative references to be able to say, within the current workspace, give me access to a particular object. And again, something that isn't available yet, but will be in the next few weeks, is the ability in a Dataflows Gen 2, instead of saying connect to a particular lakehouse and get this table, go and look in the current workspace and get, for a particular lakehouse, the particular table you're connecting to. Again, making it easier when you move from dev to test production. And then the last one of all of these kind of fairly random mixed bag of features that I want to talk about, evaluate from an API. So this came out 2 days ago. There's a blog post about it, I think, on Tuesday, and I thought, well, I've got to show this. This is pretty cool. This allows you to execute whatever M code you want from an API. So it was already possible to call an API and refresh an existing data flow. What this allows you to do is to effectively have whatever Power Query logic you want and run it via an API. You still need to have a data flow in a workspace somewhere, but you don't need to define any queries whatsoever in it. Instead, once you've got the data flow, the API can connect to the data flow, and you basically say, right, here is the M code that I want you to execute for the query. Go away and execute it, and it will get the results back through an Apache Arrow stream. So this means that you can execute a data flow through a pipeline or from your own custom code, whatever. There are limitations. Most connectors work, not all of them work. If you're connecting to a relational database, you can't write your own SQL queries and expect that to work. That would be a little bit dangerous. It'd be a security issue. And if you're executing through the API, queries can only run for 90 seconds before they time out. In the real world, data flows could run much, much longer. And I promise you in a moment, we will see lots of data flows that go for a lot longer than 90 seconds. But again, very, very quickly, because I want to get onto the really cool stuff later, let's have a look at an example of this. The blog post is pretty good, but I've got an existing data flow here. I put a very, very simple query in here, which returns a table with apples, oranges, and pears in, just to show that it's a regular data flow. But if I discard this and we should have switched over to the fabric look and feel. And we go to my notebook here. I've got some code unashamedly stolen from the blog post announcing this feature, but with a slight change. Here is my new M code for the query, which also has a product table, but has got grapes, bananas, and kiwis as the values in here. I'm authenticating, connecting to the API, connecting to that data flow that I've created, passing this M code in here, executing the query, and then getting a table of results back, which looks like this. So if you ever want to execute your own M code from your own applications or from a notebook, you can do it here, which is pretty cool. And you can imagine, not that I can say too much about this, this will be a building block for all kinds of other cool integrations across other Microsoft products that have Power Query support as well. All right. Let's get on to the really fun stuff, which is mostly performance related. Like I said, data flows have got a fairly bad rep for performance related issues. But with all of the kind of new rich functionality that we've got in data flows, I feel like we're now actually getting to the point where data flows are much faster, much easier to develop with when you're working with kind of large, unwieldy data sources, much more flexible, and actually a lot cheaper to work with as well. It's still not quite as straightforward and as easy as I would like it to be, but you know, as with all these things, it just takes one person to go away and really understand what's there, and then hopefully people get more and more interested in data flows. Now, output destinations are not necessarily a performance feature, but they are kind of relevant to some of the demos that I want to talk about, because all of my demos from now on will feature data flows that load data to a destination. Now, like I said, with Dataflows Gen2 and Gen2 CI/CD, you get to specify where a data flow outputs its data to. And now there are kind of two broad types of destination. There are destinations that we've always had with Dataflows Gen2 for the last couple of years, which are destinations which support tables of data. So Fabric Lakehouse and Fabric Warehouse are things that have tables of data in them. Azure SQL DB, Fabric SQL DB, relational databases. I think we are going to support Snowflake as a destination at some point soon as well. So you can load data to places that have a concept of tables of data. What's new since last autumn, and what you'll see a lot more of, is destinations where you can load to files. So today it's a bit limited. You can only load to destinations and create CSV files, and you can create CSV files in SharePoint, Fabric Lakehouse files, destinations, and ADLS Gen2, but there will be more destinations coming and more file formats, like Excel would be an obvious next thing to do. So this is important not only because it's a cool, useful thing, and it means that Dataflows are more of a kind of general purpose self-service ETL tool rather than a tool specifically for loading data into Fabric destinations. But it's also important because where you load your data and the fact that some data load destinations require data to be what's called staged in Fabric, and I'll explain what that is in a moment, that can also affect performance. So in the real world, if you're doing something with Dataflows Gen2 or Gen2 CI/CD, you will want to load your data to a destination, and the destination you choose and how Dataflows expect you to kind of prepare that data in preparation for it to be loaded to a destination, that has an impact on performance and cost. And when we look at some of the monitoring details of some of the demos I've got coming up, you will see that like different locations or different places to load data come at different costs. Some places it's quite quick to load data, some places it's a bit more expensive. Let me just show you how you set up a destination, because all of the demos that I show for performance will have examples where you have already got the destination already set up. So if I was to go to here, I've got yet another super simple Power Query query that just returns a table of data, nothing very interesting. But I would like to draw your attention to two things. First of all, up on the ribbon, we've got an Add Data Destination button that allows you to specify a data destination. Here, you can not only specify destinations for individual queries, you can set up a default destination. So if you've got lots of queries in your data flow that load data to the same place, different tables in the same place, and you don't want to go through the wizard that I'll show you in a moment lots and lots of different times, you can say, well, actually, I'm always going to be loading my data to this particular lakehouse in Fabric, connects to it, and therefore it'll be a lot easier to configure all the data flows afterwards. I haven't done that here. I haven't set up a default destination because I want to show you the whole thing. What I'm going to do is go down to here, to this data destination area, and there is a plus option, and this will allow me to add a data destination. I'm going to choose a lakehouse destination here. First step, I need to connect to it and authenticate. That's going to be pretty easy. And then I need to specify the lakehouse that I'm going to connect to. I'm going to connect to this lakehouse. Now, the reason I chose a lakehouse is that you've got a table section in a lakehouse, so I can load a table of data into my lakehouse. And you can see here there are 3 radio buttons. 2 say, do I want to load this into a new table that doesn't exist in my destination, or to an existing table? And there is also a third option, because a lakehouse has got a file section, and this is where I can load data to a file in the file section of a lakehouse instead. But at the moment, I've just selected new table, and it's thinking, well, I will load data to a product table here. But if I was to choose new file, which is in preview, you can see that actually there is a drop-down box, which is grayed out because there's only CSV as an option here. And I can say, well, do I want this to be a file name, product.csv, and I can choose the delimiter, the encoding and things like that. If I go back to new table and move on, I've got a dialog here which kind of maps my columns onto data types in the destination. That's not very interesting. But if I turn off these automatic settings, we can see we've got some options here. First of all, we can control when we load data to our destination, especially if we're loading data to an existing table. Do I want to replace the existing data in that table? Or do I want to keep the existing data and append new data to it? If I've got the replace option selected, I've got 2 other options here. I've got an option to use a dynamic schema or a fixed schema. So the schema is basically the columns that I've got available in my destination. If I'm replacing all of the data, well, I could actually add new columns every time the data flows run, because it doesn't matter because I'm dropping the table and then I'm totally recreating it. But I can specify a fixed schema instead, which means that I always expect to have certain columns in place. But if I was to go to append, I don't get any of those options, because guess what? If I'm appending data, I can't add and remove columns at random. It is not a sophisticated mechanism that, you know, the average data engineer would want to have. And, you know, dealing with schema drift is not necessarily very easy with a data flow. But again, the point here is to keep things simple and easy to use. I will cancel out of that. But those are data destinations. So let's talk about performance, because there's been a ton of work that's happened in the world of performance with Power Query in general. The most important thing is probably the one that is not even demoable. There is a brand new version of the kind of underlying engine underneath Power Query that's been written in .NET Core version 8. And as a result of that total rewrite, everything is faster. In particular, I believe Webb calls as well are faster. This is now on by default with all new Dataflows Gen2. So if you create a new Dataflow Gen2, you will be using it anyway. You can turn it off because it's still, you know, possibly a little bit buggy, or maybe the behavior is different. You never know, but these are preview features. But basically, this makes everything quite a lot faster. People I've spoken to who've done some tests have said they've seen things run up to twice as fast as they did before. I've got a demo here where things are a little bit faster, but still, it's a noticeable improvement. Let's go on to my performance demos here. So obviously I can't get away with tables with like about 3 or 4 rows talking about apples and oranges and pears. So what I did was download some open data. And I need some quite large open data as well, reasonably large. And what I've done is, if you go to the NHS Business Services Authority, spoiler, they are big fans of Fabric, very nice people. You'll see them at various user groups. Don't know if they've been here yet, but they've certainly done London. Most of them are based up in Newcastle, so they're really cool. But anyway, they've got some really nice open data, which is data about prescriptions. So not individual prescriptions, that would be a bit of a breach of privacy, but you can download a text file where there is one row for every doctor's surgery and every single individual drug that is prescribed across the UK. And I downloaded one 6 GB CSV file, which is 1 month of data, and that is 17 million rows of data. So a reasonable amount of data to play with for performance demos. And when I was playing around with this, this was probably the first time I'd had a go at playing around with all of these new performance related features. So I was quite curious. I wouldn't say everything is a total success, but you know, there's definitely some things here which are real wins. So let's start with my first query here, my first kind of experiment. And what I've got here is a Power Query query, which connects to that CSV file that I talked about, which is, I think it's kind of September 2023 prescription data. You can see the preview is taking a really long time to load, but what it does is effectively connect to this text file. Maybe if we go to here, it'll be a little bit faster and we can see the preview. So there's my data. And it connects to the text file, and it basically does a group by on the practice name, which is the doctor's surgery. And there is a numeric column called total quantity. And I said, just sum up the total quantity column for all the practices across 17 million rows of data. So I thought this might be a good test. And what I did here for this data flow is I actually went to options scale, and I deselected this option, which is allow use of the modern query evaluation engine. This is on by default. So I turned it off for this query. I ran the data flow. I loaded the data to a warehouse because it turned out that that was faster than before. And the next thing is, how fast is this? Well, we've got to spend some time learning how monitoring works in data flows. So here is my data flow. If I click on the ellipses here, the little 3 dots, there is a recent runs option here, where I can see information about recent runs. And if we go to the most recent run of this data flow, you can see, for example, that it took 2 minutes, 29 seconds. So I can see how long the data flow took. But more interestingly, I can go here and I can see more detail. So I can see the overall duration here. And what I can see here is also a bit of a breakdown. I've got a table section and activity section. The table section tells me how long each of the individual queries inside the data flow took to run. So the query here, EPD 2022-09, is the query that connects to the source and does the group by. Connects to a CSV file, reads the CSV file, does the group by query. The activity, as you can probably guess from the name here, is when I've done that, load the data into the warehouse, which could also take a little bit of time. Now, the good news is if we have a look at the activity, the write to data destination, we can see that there were 8,411 rows written. It was loaded into the warehouse, and that took 12 seconds. So that's pretty cool. That was nice and fast. If I go to here, what I can see is that I've got the actual query. It took 1 minute, 59 seconds to run without the modern query evaluation engine enabled, and that returned 8,411 rows. So we can break down the performance of a data flow and split that performance between how long it took and so on. If I compare that overall performance of 2 minutes, 29 seconds with the same query with the modern query evaluation engine enabled, which actually I won't even open because I shouldn't do that. It's not really very interesting. It's the same query, just with that option checked. And we go to recent runs. The query only took 1 minute, 49 seconds, 10 seconds faster, not all that much better. But we can break that down, and there we are. In this case, that query, that group by only took 1 minute, 19 seconds. Not sure what happened to the rest of it because the loading of the data was still pretty quick. But don't need to worry about the modern query evaluation engine. Enable it if it's not enabled already, and it will just magically make things faster. There are 2 other performance features, though, that are worth talking about. There is fast copy and staging. Actually, there's 3. But before I go on to that, there's something else that I did in this particular query, which is a really handy, useful feature. Probably my favorite performance feature out of all of them, preview only steps. Now, who's been Power Query Editor and sat down and it's been really, really slow to evaluate, like we just saw? What you can do now in a Power Query query, if we open up one of these Power Query queries, is you can apply a filter and have that filter or that step or that transformation only apply when you're in the editor. When it actually runs the data flow, it ignores that step. So what I've got here is a step that filters on practice names, so only getting data for one practice. And the key thing here is for this particular step, I've got enable only in previews selected. And that can make the editor much, much faster, much more responsive. and you get a lot less frustrated as a result. Okay, go on quickly to staging. Staging and fast copy. These are two kind of less interesting, less useful optimizations. Staging basically says inside a data flow, you can have multiple queries, and queries can connect to other queries. By default, in the world of Power Query, if you have one query that uses another query as its input, they just basically chain together and the data flows from one to the other in memory. In a data flow, you can say, actually, I want to stage the output of this query, which means that it gets stored in a hidden lakehouse that the data flow creates in the background. So you have the overhead of loading that data into the lakehouse. But once the data is in the lakehouse, it's local, so it's easy to get at. And every lakehouse has got a SQL endpoint, which means the data there can be queried in SQL. And because the data is now available to be queried in SQL through the warehouse engine in Fabric, guess what? Query folding happens. So all of your kind of complex joins and group bys and things will be way more efficient than if they happened in the Power Query engine. But you've got to take that hit of staging the data in the lakehouse, in this hidden lakehouse first, which can be very slow. So there's a bit of a trade-off here. First of all, how quickly can you load your data into a lakehouse? There is an optimization that you will see pop up in the UI called fast copy. Fast copy is something that can happen for certain sources, and it will happen in certain situations. For example, where Dataflow sees that you've got a file that's larger than 100 meg, or you've got a table in a relational source that's got more than 5 million rows in. And this basically swaps out the regular Power Query engine for the copy activity engine that's also available in Fabric. Now, this is faster at moving very large amounts of data. The bad news is that it's very limited in what it can do. And I'm going to put my hands up here. It's pretty much only useful if you are moving an entire table of data or an entire CSV full of data from one place to the other. In my tests, the modern query, regular data flow with the modern query evaluation engine enabled was actually faster than fast copy. But the good news is something you can turn off, something you can kind of ignore. But if you're worrying about fast copy, don't. It's probably not all that useful. But certainly staging can be really, really useful. So let me show you a more complex example. I did actually have a go at staging the data for that previous scenario that I showed you, because you remember there was a query there that did a group by on a large amount of data. So I thought, well, why not copy the entire contents of the CSV file into the data flow, stage it, and then the group by is going to be really, really fast because it's working on the SQL endpoint. The bad news is, if you look at the performance of this, it then took 8 minutes 19 seconds to do, as opposed to 2 minutes. And the reason is, if we look at the breakdown here, I've got a query called stage data, which is the one that stages the data. And we have a look at this. That took 7 minutes 31 seconds. Now, once I'd staged the data, the group by took 14 seconds, which was great, but you've got to be working with a very large amount of data to be able to take that hit. So I thought, all right, that's not a great demo. What I did instead was come up with a way more complex example, and I'll just show you the stage version. The key thing you've got to bear in mind is, are you going to be doing some transformations which would involve going back to the data source multiple times? That's quite often a scenario where staging is going to be really useful. So what I did here is take the source data, which is that big CSV file, and I said, let's go through that CSV file and let's get a list of doctor's surgeries that prescribed a range of drugs that are very rarely prescribed. There's a scheduled drugs list, and maybe we want to have a look and see which surgeries are prescribing 4 of these scheduled drugs. So I want to take all the surgeries who prescribe captopril, all of the surgeries that prescribe gabapentin, all the surgeries that prescribe fentanyl, and all the surgeries that prescribe lorazepam. So 4 filter queries that will have to go back to the source 4 times. And then let's do an inner join between all of those 4 tables and get all of the surgeries that prescribe every single one of those drugs. And when we got that list of surgeries, go back to the original table, do an inner join, and find the total quantity for all of those surgeries. So I thought that's got to be a scenario where staging is going to be useful. And indeed it was. Because going back to that CSV file, every time you did a filter, it took about 2 minutes. So you do it 4 times, it ends up being fairly slow. So if we have a look at no staging and we have a look at recent runs, the query took about 7 minutes. The data flow took about 7 minutes overall. But with staging enabled and copying all of the data from the CSV file over, and in fact, I didn't copy all the data, I just copied only the columns that I wanted, which made things faster, which is pretty useful. We can see that the query now took 3 minutes and 7 seconds, which is good. And if we have a breakdown here, the actual staging took 1 minute 40 seconds to stage all of those 7 million rows, which, like I said, was much faster than the fast copy engine. Right, that's good. And then up here, when we do all of those complex transformations, they took 59 seconds. But they all took 59 seconds because it was basically just now a bunch of joins in the warehouse engine because all the data was available from the SQL endpoint. And instead of all of those joins being horrible and slow in the Power Query engine, they're super fast in the warehouse engine, and the group by afterwards, not too bad either. So staging can be useful, but you've got to really think about it. The confusing thing is staging can sometimes be turned on by default, and you can actually get a performance boost by turning it off. So be aware that it's happening and maybe turn it off. Last performance demo thing that I want to talk about is something called partitioned compute. I know I'm over, sorry. I will finish off fairly quickly after this. This is the last substantial thing that I want to talk about. Partitioned compute is another new optimization, and it allows you to do parallelization. So basically, it allows you to say, if there are certain operations inside my data flow that can be run in parallel, let's add an extra step to do, to tell the engine that these things can be parallelized, and it will go and do that. The way it works is by you saying, okay, I'm going to take everything that can be parallelized and turn it into a function. And then I'm going to have a table where I call the function once per row. And then I say, okay, here is a column that allows me to describe which things should be run in parallel. It'll go away and run that. Sounds very complicated. The good news is that there is one scenario out of the box where it will just work. Has anybody used the from folder transformation with Power Query, where you connect to a bunch of files in a folder, you can apply the same transformations to all of the files and then turn it into one big table? This is exactly what partition compute is designed for. Should work out of the box. It's not working out of the box quite at the moment, but there is a little bit of extra code that you can add. And what I did here for my last demo is basically upload another month of data, another 6 GB file, and then use the out of the box functionality to do a combine files. So I said, okay, let's go to these 2 files in a lakehouse and combine them out of the box. And like I said, when you do that, all of this extra stuff here, which has been around in Power Query forever, it creates a little function to get the data from one file and then iterates over the folder, calling the function to get the data from each file. Now, this is the unoptimized version. So it will basically run get the data from the first file and then get the data from the second file. And if we have a look at recent runs, that took 2 minutes and 2 seconds. And if we have a look here, there is just one table evaluated. Also note that the engine is blank here. If you go to the with partition compute enabled query, we go to recent runs. This only took 6 seconds faster. There's an overhead to doing this, but what you can see is now in activity, there are 2 separate activities, 2 separate runs. And actually the duration here was 1 minute and 25 seconds. So it was faster overall. This is pretty useful, but it will roll out more and it'll just work in the UI for the scenarios you want it to work. You can write the code to do it. Okay, I'm already over and this is already too slow. Last thing I want to talk about is migration. So you're using Dataflows Gen1, you got maybe a Dataflows Gen2 regular, and you want to go to Dataflows Gen2 CI/CD. Why do you want to do this? You want to use all of this new functionality. You want faster performance. Dataflows Gen2 CI/CD is cheaper as well, so do that. Faster is cheaper, and there are also different pricing options for different things as well. How do you migrate? You can migrate manually, very easily. So for example, if I go to a folder that I've got here with a Gen1 data flow in it. So here's a Gen1 data flow. I can simply click on the ellipses here and I can go and save as Dataflows Gen2. I'll do it manually. Otherwise, I want to do a very quick advert for my colleague Pat Mahoney, who's also on the CAT team. He has actually built a series of scripts that are available in the Fabric toolbox, which is a GitHub repo with loads of useful things in from the CAT team. And what this will do is it's got notebooks, which will not only allow you to use a script to migrate individual data flows, you can actually connect to whole workspaces or indeed your entire tenant and migrate them all to Dataflows Gen2 if you want. Check out the repo. He's also got a video on his YouTube channel, which is called Hoosier BI. He's American. Hoosiers are from Indiana, I think. I can't remember, but that's his YouTube channel. All right, that's me done. You can see overall there are tons and tons and tons of new things in Dataflows Gen2, way more than the 45 minutes that I should have used. Sorry for going over. I'm sure the pizza is going to be here anyway. I will take questions in the break with the pizza. Thank you very much.